transfer function is equal output over input, output over input, y omega over x omega, output over input. And after that, we have the one magnitude for the transfer function and one phase. Okay. The transfer function h omega of a circuit is the frequency dependent ratio of the phasor output and element voltage or current to a phasor input x omega. It means that the frequency response. It means that the y omega is equal h omega times x omega. If you remember that if the y output in the time domain, you should solve this equation. What is the equation? Convolution equation. And convolution equation is very hard because it's with integral. Have you remember that we have in the circuit and in math how to the signal or especially in communication. What is your question, madam?
They need the 7 equivalent of the circuit. They need the Z the Thevenin and V Thevenin. For the Z Thevenin, I'm a little bit confused about how can we calculate it here.
Z Thevenin and V Thevenin. Okay. Yes. A and B, Z Thevenin. What is a Z Thevenin? Huh?
Yes.
Okay. For Z Thevenin, we need here is current, and here is we have for example 1 volt. And 1 volt, if you can show that the Z Thevenin is equal 1 over I, voltage over I, okay? But current is here. In this current, we have 0.2 V0 plus 0.2 V0 plus this current.
But I think that one was for all frequency, not for resonance. That question was for all frequency. Because L and C is given.
Yes, just a moment. Filter for the is the output is the across for the R. Okay. But the filter is RLC. You can check your slides. RLC is output is not given from the resistance. It's given for the capacitor or inductors. It's not make sense because because the J omega is equal 1, because it doesn't matter it is band pass filter. But band pass filter, to be honest, you can see is here because for the mixture, it means that the 1 is not for the all of the frequency 1. Why uses all of the frequency 1? Because your output is here. For the filter, output is here.
And we have a L 2 millihenry and C 0.5 microfarad, I think so.
No. Farad. It's here is V out over V in. This is at frequency is V out over V in is here.
Excuse me?
Yes.
In this case, we can mention that the matrix is here. Summaries of the resistance in one loop for Z11.
Yes. For the every time is for the looking for the Z and the admittance is only for the 2K. For the admittance is better than using the KCL. For the impedance is better than the volt for the KVL, and only find the relationship between V1, the left side, I1 and I2 right side.
No,
V2
means that directly we can mention the matrix.
Yes, you can do it. I remember that. It means that you want to. It depends after your question. You want to this year, for example, you can another method. Yes, for example, can you see my screen or not?
Yeah.
Okay, for example. Yes.
Example.
For example, Z11. Yes, you can do Z11 is equal V1 over I1 if I2 is equal 0. Another method you can do it. For example, Z12, it means that V1 I2 V1 over I2 be if I1 is equal 0. But I1 should be 0 and check that. Yes, you can do it. Here, okay.
No, if you scroll it down.
Here, it's here. You asked me here, yes?
Yeah.
Okay. Because we know that for the S1 and S2, if you remember that, it is a complex number here. Complex number. And if you remember that S1 and S2 is alpha plus beta J, we know that our result, for example, VAT or IAT, VAT is equal A alpha T, C1 or for example A1 cosine beta T, and plus for the A2 or B, doesn't matter, sinus beta T, okay? And after that, we can find S1 and S2 is 0 plus 1J. We can see 0, positive, negative, J, J1. Its here is 0, its here is 1. Okay, now we can write E power 0 is 1. A for the cosine beta is 1, is alpha, beta is 1 cosine T plus B sinus T. Okay, make sense?
I got it. Yep.
Okay, because it's under them. It is a for the one node in under them. Any questions so far? Okay, but I assume that you can solve any problems if you have the, what is the name about the any equation with the source. For example, I share with you this file for the RC and RL. If there is RC and I want to show that some RLC, for example, here is R here. For example, here, and here is very important for the using that. Here is what is the problems is here. Here is, you can see RLC series, but without source. Without source is easy, no problem. Okay, this module is focuses state, and as I told you, please listen to me. We have one question, mod, nodal, and mesh. You have to, I think that for the only follow up me, you have to more than 70%. If you cannot 70% pass this course, immediately after the find the road result, immediately go to the hospital for the show that the mental. What is the problem? Panavaran in a situ. Module 3 is we have the circuit theorem. At least one question, but maybe it's a circuit theorem. Your question is the phasor analysis. And module 4, we have the capacitor and inductor. Module 5 and first order together, we have at least one question. One question is here, is question number 4, and AC question is number 5, and at least one question from the frequencies response and Laplace transformer. And I saw that this is the one part is recently, and one question about the, for example, how to define the Z impedance. It's better than now. It is about that you, but remember, it is a two-port voltage V1, I1, and V2 and I2. For the two-port, we have a lot of the matrix Z, matrix Y, matrix admittance, matrix T, matrix same as a power system, and T prime, and matrix hybrid, and matrix G. And for the matrix Z, is we know that V1 I1 is equal V1 V2 is equal Z11 Z12 Z21 Z22 V2 times I1 times I1 and I2. Sorry about that for this. I1 and I2. You can see this is relationship is for the, what is the name for the two ports. Okay. And module 10 is for the modular and time. Is it together? For the we have the one question. Okay, doesn't matter.